All right, this is section 3.3 in the, we have started, if you haven't noticed. This is section 3.3. We just finished doing systems of equations. We're going to do systems of equations again. Let's try this again. So we've done systems of equations, but how many equations did we do? How many variables did we solve for? We solved for 2 variables. Take a wild guess on how many variables we're going to solve for this time. 3 of them. Okay? 3 equations, 3 variables. I don't know if I mentioned this before. I know I did in maybe 1 or 2 of my other math classes. If you have 3 variables, if you have to solve for 3 variables, just say x, y, and z, you must have 3 equations. You can't just have 1 equation with 3 variables and solve for all of them. You can't have 2 equations. You got to have the same number of equations as you have variables. So if you have 2 variables, you must have 2 equations. If you have 3 variables, obviously you must have what? 3 equations. So they start off right with an example. They don't really do much. They might do a little bit of teaching. I just didn't write it all down. Okay, so in my notes, I just started with the example. I thought that'd be the easiest way to teach this. So let's write it down. Yes.
This is kind of an off question.
Go ahead.
So you have like 3-dimensional axis, you have x, y, z.
Yeah.
You have 4-dimensional axis.
There's not. That doesn't exist.
But if you did, would the 4th axis be a? You already have.
There's not. So there's not an if.
But if.
There's no if. It doesn't exist. You can make it whatever you want. All right. Just put it right there. No, we're not getting that deep, okay? Now, this is 3-dimensional. So, you know how we have an x and a y axis?
Yes.
That's 2 dimensions, okay? There is actually a 3rd dimension, all right? And we live in 3 dimensions. It's not like some spooky woo, kind of thing. Okay, 3 dimensions is something that we live in, okay? We have, what's the word I'm trying to think of? You have length, you have width, and you have depth. The depth is the 3rd dimension. A lot of times they'll do this by putting like a dotted line right there. It's kind of hard to see this on 2-dimensional paper, but basically if you had like a corner, right, of a wall or something, you've got one line coming this way, you've got one line going that way, and then you got one line going up, okay? So you have depth. So that's what the 3rd dimension is. So this actually can be very, very practical. All right, so we're just, in this lesson, in this class, we're not going to get really practical. And I hear that all the time. Well, never use this. But to tell you the truth, high school math is not really designed for you to use it when you learn it, okay? And you're like, well, why are we going to learn it? It's basically, it's creating a foundation. We're building a foundation, all right? If you're going to build a house, right, you know the proverb from the Bible, you don't build it on sand, right? You build it on solid rock. That's what we're trying to do. We're trying to build a solid foundation so that you can build upon it. When we start building upon it, that's when people actually start using this in real life. Don't ever tell me that math is not important and nobody uses it. People use it all the time. You use the math all the time. You may not do the math to create the things all the time, but you use it all the time. Just being in this building, you've used math. Being in a car, using your computer, doing anything, sitting in that chair that you're in right now. People have used math to be able to create these things, okay? Not everybody does the math. Not everybody creates these things. But if there weren't people that created all this stuff, we wouldn't be able to use it. We'd be back, in the caveman days, just sleeping on the ground, okay? Math is super important, all right? And it's very practical. If you take, I don't know, is anybody in physics this year with Mr. Rao? Anybody taking physics? Probably not. So if you were to take physics, you'd find out that's really where it starts getting practical. In chemistry, it gets very practical. You use a lot of math in those situations. A physics class is basically like a upper level math class, but you actually use and you apply the math. You apply the equations and the theorems and the laws and all that kind of stuff that you learned earlier. All right, that's where the application starts. But in a class like this, there's not a ton of application. There is some from time to time, but we're just laying down a foundation. All right, enough of that. let's keep going. That's a z. That's my z. I always put that little line right there because sometimes my z's and my 2's can say that's a 2, right? And that's a z. Who knows which one it is? Well, now you know, right? That's the z. Everybody got it? Well, sometimes I do it too like that. Sometimes I get sloppy and do it like that. All right, enough of that. That's a 2z equals 9. And then one more equation because we got 3 variables. I've got 3x minus 3y minus 2z equals 1. All right, and they put this little brace right there. Why did they put that little brace right there? Well, yeah, the x's are all the same, exactly right. The x's are the same, the y's, the z's, they all equal. So whatever you get for x, it will work in any of these equations. Whatever you get for y, whatever you get for z will work in all these equations, okay? That's why they put this. This is a system of equations. They're all together. They're not just random equations. Everybody understand that, right? Okay, so what do we do? Well, first thing I'm going to do is I'm going to number these equations because we're starting to get more than just 2 of them. So that's going to be 1. We'll call this equation 2, and we'll call this equation 3. All right. Now, what we're going to do is we're not going to do them all at the same time. You know how we did the 2 equations? We got rid of a variable, all right? And then you only had 1 variable left. But if I just get rid of 1 variable here, how many variables do I have left? I got 2 left, don't I? X, could you please stop? So what we're going to do is we are going to try to pick, we're going to do a couple equations. We're going to pick either 1 and 2, 1 and 3, or 2 and 3. Is that the only options? I think that's it, right? Did I say 1 and 3? Yep. So we're going to combine them so that I can get rid of a variable. But I want to look at it a little closer because if I get rid of a variable, like for instance, I think I did, let's see. Let me just see what I did. Yeah, you could do it either way, all right? For some reason, I picked 1 and 2. Now I'm looking at it and I'm like, why didn't I pick 2 and 3? But that's okay. It doesn't matter. The thing is, it doesn't matter which 2 you pick. I'm just trying to pick the 2 that are the easiest, all right? So do I want to get rid of the x's? Do I want to get rid of the y's? Or do I want to get rid of, when I say get rid of, eliminate, right? The z's. What do you think would be the easiest to get rid of? Probably the z's. And why? I see this 2z and minus 2z. That's a key right there. And then if I was to combine, let's say, maybe the first one and the third one, I could get rid of the z's easily there. Or even the first one and the second one. Agreed? Like if I was to do 1 and 2, if I was trying to get rid of the x's, all right, well, what would I have to do? Well, I'd have to multiply that by a -2 all the way through, then I could get rid of stuff, right? And then if I was to take 1 and 3, put them together and get rid of the x's, I'd have to multiply that by a 3 and that by a -2. You could do it. It would work. It would work, okay, but it would be a little bit more work than we really want to do, all right? So I'm just going to go by my notes so I don't get lost, all right? So I'm sure I could do it the other way. But what I'm going to do is I'm going to get rid of the z's. So let's take equations 1 and 2 and put them together. All right, so what I'm going to do is just off to the side, I'm just going to rewrite equation 1 and equation 2. So let's do that. You should be doing it as well. If all you're doing is just sitting there and watching, or if your head's down, you're not doing what you're supposed to be doing. So write down this. This should be in your notes. All right, so I took the first and the second equation. I could have taken the second and the third, and now looking at it, I'm not sure why I didn't do that when I did this problem in my notes, okay? But that's okay. It'll still work either way. It doesn't make any difference, all right? And so what do I want to get rid of, did I say? The z's. I want to get rid of the z. All right, so how would I get rid of the z? I'm going to have to do something. Very good. Not just by 2, though. I would multiply it by something else. Because if I add them up, I want them to add up to 0, correct? All right, so if I make this into a -4, then when I add everything up, the z's will cancel out. Everybody with me on that? All right, so let's do that. Let's multiply this by a -2. And of course, we have to do that to the other side as well. Oops. All right. So now, let's write it down. I didn't do anything to the top, so I'm just going to rewrite the top. All right. And now I'm going to multiply everything by the 2 and put it down here. So this is going to be negative 2x. This is going to be negative 4y. And this is going to be, oh, I know why I did this. Now I remember. And this is going to be negative 4z. And this is going to be negative 18. All right? Let's push this up a little bit. Now we're ready to get rid of the z's. But look at what else eliminates. The x's eliminate as well, don't they? So it's kind of like, what do they say? Kill 2 birds with 1 stone, right? Probably not the nicest example. We don't really go around killing birds with rocks, but that's what the phrase says. So look, the z's will cancel out, okay? And what else cancels out? The x's. Wow, that's kind of nice. So now I'm not just left with 2 variables. To tell you the truth, I wish they would have given a different example. I think they made this example a little bit too easy. And then the other 2 examples are ones where you get no solution or all the real numbers. So I really wish they would have given you like a normal one where you get real number answers, but it didn't do this. Anyway, that's okay. You'll probably get some of them in the homework, all right? But this does work out kind of nice and kind of easy. So those cancel out. So now I'm just left with 1 variable, which is nice. So I've got what? Is it? I'm going to add up the columns. This is plus 1y, right? And minus 4y. So I get a negative 3y. Agreed? Looking at my notes. Where did I do that? Oh, it's right there. Yeah. Negative 3y equals what? Negative 6. Divide by negative 3. This works out real nice. So y is 2. I'm going to circle it. Now at the end, remember how on the other equations, when we had 2 equations, how did we write our answer? As an ordered what? Pair. How do you think we're going to write our answers to this?
Ordered triplet.
Exact. Well, almost. You almost had it. An ordered triple is what they call it, okay? Trio means the same thing. Triplet's fine, but they don't call it that, okay? They call it an ordered triple, okay? So that's what we're going to do. So there's one of my 3 answers. So once I get that, I could, let's see what I want to do. Yeah, I could substitute that into any of these equations up here I wanted to. You know what we could do? I'm gonna break off my notes a little bit. I want to try something else. Now that I'm thinking of it, it might be better for you. Do you see these 2 right here? What can you get rid of here just by adding those up? The z. Let's do that. Is that all right? I'm not going to rewrite it again. Well, I'll tell you what. Since I got this little computer deal, I'll just copy and paste it. So there it is. So I did rewrite it again. That was quick, wasn't it? All right. So now, look what I can do. I'm going off script here, so bear with me. All right. Hopefully we'll still get it right. We should. Thanks. At least one person does. So watch. So those cancel out. So let's add up everything else. When they cancel out, it's because we're adding everything up, right? They add up to 0. So what's this going to be? 4x. What's this going to be? Rep minus y. That's 0 equals what? 10. Now, look how easy this is. Now I know what y is over here. So now what I can do is plug it back in here. Now remember what I said? I wish they wouldn't have given one that came out this easy. Like your quote normal, all right? I guess if there's a normal one of these type of problems, what you would really do is you would eliminate the z's, then you would have had like an x and a y here, okay? And then you eliminate the z's here, then you have an x and a y. So like your quote normal equation, you would come out to an x and a y here and an x and a y here. Then you would put those together, and then you would do substitution or elimination to solve for x and y. Does that make sense? All right, but this one just happened to come out where both of these things eliminated and I have y by itself. That's not, quote, normal, all right, for these kind of problems. Most of the time, you'll get one equation with two variables, like an x and a y, and then you'll combine a couple of these other ones, and you'll get an x and a y, and then you do what we did basically on the quiz yesterday, if you did it right on the quiz yesterday. All right, so let's do this. So now we know what y is, so what can we do with that? I could put it into any of these, but then I'd have an x, wouldn't I? I'm sorry, but then I'd have a z and an x. All right, so this has an x and a y, so if I put that 2 in for that y, I can easily solve for x. So let's do that. So this is going to be 4x minus what? 2, not 2y, just 2, because I'm replacing it. Substituting a 2 in for that y, equals 10. Yep, plus 2, so 4x is what? 12. Divide by 4, x is 3. So that's 2 of the 3 things. Now I got 2 of them. Now I got a lot of choices. I got to solve for what now? I got x. I got y. I got to solve for z. So look, anything with an x, y, and a z in it, or anything with a z in it, right, I could solve for. So, I don't know. You got a bunch of choices here. What one would you like to use? The third one? Okay, let's use the third one then. So I'll keep that right there so I can see it. So let's write it down. So I'll just write it all down so you see what we're doing. 3x minus 3y minus 2z equals 1. So let's start substituting. So I know what x is, so it's 3 times what? 3 minus 3 times y. I know y. It's 2. And I don't know z. That's what I'm solving for. So I put just minus 2z equals 1. See what I did? All I did was just rewrite that third equation. But now I just stuck in x and I stuck in y. It's like a double substitution. Now I can solve for z and I'm done. That's it. So let's do it. This is 9 minus 6 minus 2z equals 1. 9 minus 6 is 3 minus 2z equals 1. Subtract a 3. All right, so it's negative 2z equals negative 2. Divide by negative 2. Z is negative 2. Forgot the negative right there. Yeah, z is 1. So there's my 3 answers. There's my x, there's my y, there's my z. But how should I write it? As an what? Ordered triple. This time we got 3. So what do you think the order is? It should be pretty plain. X, y, and z. So what goes first? What number? 3, comma, 2, comma, 1. And that right there, 3, 2, 1.
Wow.
All right? That's your answer right there. That's what your answer should look like. All right? So, let's do another one. I know. It is easy, though. If it looks easy, it probably is. But you're right. You got to practice this. You know what you could do? Listen, you know what you could do? You could go home, right? You already know what the answer is. You already know how to solve it. You could write the problem down again from scratch. Don't have any notes or anything. And then just try it, right? You may find a different way to do this, right? You may not do the exact same steps. You don't have to, right? There's all kinds of ways you could solve this, not just this way. In fact, I solved it different in front of you guys than I actually did in my notes, but I came up with the same exact answer. And I believe I solved it different than what the book did. I think the book did it a little differently than what I did. So there's 3 ways right there, okay, that you could have solved this problem. So give it a shot. Give it a try. All right, let's do example 2. Now this is one of those ones where it's going to come out to be either no solution or all real numbers. So let's see what happens. Everybody ready for this one? So let's write it down first of all. Plus y minus 3z equals negative 3. Let me ask you this. They don't do this on these examples, but what if, we kind of did this on the quiz, what if they don't put them in order? What if we put that negative 3 over here and it was a positive 3? They put the x over here, whatever. Then put them in order, okay? That's the first thing you should do. They did it for you already, all right? But you need to make sure you put them in order, x, y, z. All these are x, y, z. They could use other letters, but just put it in some semblance of order so that everything lines up with each other, all right? So you make sure you do that first. Again, on these examples, you don't have to worry about that, But you never know. I haven't looked at the homework problems like exactly, so I don't know if they do that or not. They could put fractions in here, but how would you normally get rid of a fraction? Get rid of the denominator by multiplying everything by the what? The denominator, or a common denominator. Okay? So all the stuff that we did with two equations, that comes into play as well with this. This just is an extra step or two. Well, maybe more than just one extra step. All right. So yeah. So what do you want to do? What's that? 2 and 3, and what do you want to get rid of? Okay, so let's do that. I think that's a good choice. Is that what I did? Yep, I did. Go ahead, ask.
So could you like add all three together and then like
No, because look, if I added all these together, I'd still have one equation with three variables.
yeah, but then could you like shift the others over?
You don't want to do
by
that.
itself?
I'll tell you right now, you don't want to do it. You can try it on your own if you want. There probably are situations, depending on what numbers and signs they give you, that you could do that. I would not count on that every time. Okay, I would not do that. I think it's going to make it more confusing. What I would do is what Faith said. I would do 2 and 3. Okay? So again, I'm just going to copy and paste. Sorry you can't do that on your paper, but here it is right here. All right, because I answered one person's question, then half the class starts talking. Is that how it's supposed to work? Don't think so. Let's do this. So Faith says she wants to get rid of the y's because it's tailor-made for you, isn't it? It's made for you to get rid of the y's right here. So I would absolutely do that. So cancel those out. They cancel out because we added them up. They add up to 0. So you add up these, you get a 7x. You add up this, you get a negative 2z. And you add up those, you get a negative 5. Wait a minute, did I? Yeah, I did 1 and 2. Why did I do 1 and 2? I don't know why. I would do it this way. So now, I'm going off script again. All right, this is not what I did in my notes, but I think we can still figure that out. So there you go. I got an x and a z. So now, let's go back to this. What other combination can I use to get rid of the... So I tell you what, I'm going to put this like in a little box. It doesn't mean that's the answer. I'm just putting there for safekeeping, all right? Because I know when you start writing all this stuff down, everything gets mixed up, right? You lose stuff. So I'm just putting it in a box so I don't lose it, okay? So now I got to get rid of y another way. What's the other way? Using what equation? What two equations? 1 and 2, right. I'm going to use 1 and 2. So again, let's just copy and paste that. And let's just do that over here. But we got to do a little bit of extra on this one. We did it in the last problem. What do we have to do to eliminate the y's? Yeah, multiply by 2. So multiply that by 2. And multiply that by 2. Remember, I have to multiply everything on that side by 2, not just the y. All right, let's see what we get now. Let's multiply everything by here multiply everything by 2 right there. So I've got what? 4x plus 2y minus what? 6z equals negative 6. Good. We don't have to do anything to the bottom, so I'm just going to rewrite it. So 3x minus 2y plus 4z equals 2. All right. Now we're ready to add up all the columns here. Now I can eliminate the y's on these. So those go away. 4x plus 3x is 7x. And what's this? Negative 6 plus 4 is negative 2. And negative 6 plus 2 is negative 4. Okay? I'm going to put that in a little box. So look at the two things in the boxes. Anybody still paying attention? It seems like I got 3 of you actually writing stuff down and watching me. All right, I'm just going to keep going. If that's your choice, that's your choice. You just have to live with the consequences. All right, so let's do this. I'm going to copy and paste this. I'm going to put that here. I'm going to get rid of the box, though. Don't need that.
I think really just more confusing by like not showing us how to do
All right. So watch this. So this is what we're up against. Okay. Does this look kind of familiar to what you did before? Yeah, it does. So what could I do? I could eliminate stuff, couldn't I? What could I eliminate? Well, just do this. If I add the columns up, it's not going to eliminate anything. So what am I going to have to do in order to add the columns up and get rid of stuff? Yeah, make that negative, change the sign of that, change the sign of that. Now I can add the columns and stuff's going to eliminate. In fact, too much stuff's going to eliminate, isn't it? Because what happens? That cancels. That cancels. What does that all add up to be? 0. What's that add up to be?
1.
How about -1? It really doesn't make any difference. Is 0 equal to -1?
No.
No. So this is no solution. All right? So they gave you one of each. They gave you one that actually comes out to real numbers. They gave you one that came out to no solution. Take a wild guess what the next one's going to be. It's probably going to be all the real numbers. All right?
They should have done like 2.
Yeah, they probably should have. I agree, because that's what I said at the beginning. They should have done 2 that came out to real numbers, but that's okay. You'll have plenty of chances to practice when you do the homework. All right, here we go. One more. Let's do it quick. Running out of time. I only got like 6 minutes.
This one's going to be all right.
Well, you would think it would be, right? You would think, because they are examples in the book. Most of the time, they don't give you examples that are exactly the same. They always have a little bit of difference between them. All right, with examples in a book. Have you noticed that in a math book? Yeah. So let's do this one. This one's actually pretty quick. You'll see it right off the bat. Oh, this one, they don't even put a Z in there. They just give you 2 of them. Look, this one has 3. This one only has 2 of them. So what do you think you want to do here? Let's see what I did. Oh, here we go. Yeah, that's what I would do. I would take, see, this doesn't have a Z in it anyway. Everybody see that one? So I'm going to put that in a little box to save it. All right, so that's got 2 variables. That doesn't have a Z, so I eliminated the Z. Right here, let's just take these 2. And let's put this up here. All I did was just rewrite those again. So look, this is tailor-made for you to eliminate the Z's. Watch what happens. Cancel, cancel. Add up all the columns. That gives me a 5x. That gives me a -y. Check this out. This gives me a what? A 4. Look at these 2 things in the boxes. They're exactly the same. So, to tell you the truth, I would say you don't even have to go any further than that. Anybody paying attention? I got people turned around. I got people looking the wrong way. Just don't get it. It's crazy. It's just crazy. So, I don't care if you're ready or not. Sometimes you just gotta learn. Doesn't matter. Here we go. So look, these are both exactly the same. What does that indicate to you? Like, what value can I put in for X and put in for Y? I could put anything in, all right? Because if I put the same X in here, well, actually, trying to think. It's not exactly true, because I can't put anything in for this and anything in for this in order for that to come out to be a 4. Well, that's the answer, though. The answer is all the real numbers. So we'll just keep it at that. And maybe I'll talk to Mr. Rao and get the finer details of this worked out a little bit. Because now that I'm thinking about it, we're just going to write down all the real numbers right now anyway. Because they do say that, but then they do something a little bit different. And I thought maybe they're just trying to show you something else. But in there they do say that it's all the real numbers, but they don't give it to you as your final answer. They do this weird thing. They don't just say, here's the answer, circle it, you know. They do something kind of weird. Yes?
So, are we going to have to graph these eventually? So when we have to put it in the y equals in that?
Yeah, you could think of it that way. That's a good way of doing it, right? If you were to graph it and then solve for it, it'd be all the real numbers, wouldn't it? All right. So y, put this over there, put this over here. So y equals what? 5x minus 4. No, because I put this over here. All right. So that stays there. That goes over here. Plus 4. Yeah, no, it's minus because you subtract it, right? So you're right. And if I did that, it's the same exact thing. And if I graphed it, yeah, they would just be two lines that are on top of each other. So yeah, I think saying all the real numbers is perfectly fine. Okay. Yeah. Okay. Yeah, I think we did good today. We finished a whole lesson. It's rare we finish a whole lesson. It was kind of a shorter lesson. Usually they make these lessons crazy long. So let's see. I didn't write the homework down. Let's look at the lesson plan thing. Lesson 3.3. 13 to 26. So that's what you're doing. That's not that many. It's kind of a many, but that's all right. Let's do this. I'm going to eventually give you all of them to do, but I'm splitting it, and I don't know if this is a good choice or not, because you guys do terrible working in class on your own. So I don't know. Maybe what we can do is I'm going to give it all to you, but I'll give you 2 days to do it. All right. So maybe tomorrow I'll spend the time going over these. Okay. It's page 188. I'll put it up on the screen, so if you need to take a picture of it. All right. So there you go. You don't have to. I'll tell you what. Listen. I'm not making you do all of them tonight. So, if this looks overwhelming, don't just say, I just forget about it, I'm not going to do any of it. Do at least half of it. I don't know what number up to. Do whatever number you can, okay? We'll go over those tomorrow, and then we'll see if we have time left, if you can do the rest. But this will be due, not on Monday, because we don't have school on Monday, so this will be due on Tuesday. So we don't have school on Monday or Friday of next week. We only have 3 days next week.